Right, today we are going to cover XQuery Extensions, part of our database training. We'll go over extensions, query, value, exists, modify, the nodes method, and I call it FLWOR, a way to kind of iterate over an XML stream. So a quick overview, we'll go over each of them, then we'll do some demos. So query, you use it to extract XML fragments. The output is XML. So you can see here in this little XML sample, we use dot query and item name to pull out any nodes that match that. So you can see here that name, category tools gets returned. If we use the query method with item quantity on hand, then we get the quantity on hand XML fragments. The dot value returns the the value of either the attribute or the node itself. Here we used items name and the @category attribute, and we've got tools. The little square brackets here denoting which occurrence of the node you're looking for is required. In the second one, we say return the value of the first occurrence of the name node, which is ax. You could have multiple name nodes, in XML, multiple occurrences of the same node. So when you say value, you have to specify which one you want, the first one, the third one, the 10th one. The exist method will return a 0 or a 1, depending on if that attribute exists, if that attribute value exists, if that node exists, and it scans the whole level that you're looking at. So if you only have one, it'll return true. If you have 100 of them and there's one in there, it'll return true. It's just a handy quick way to check to see if something exists. The modify method, it only works with an update statement, and you use it to update kind of the value or the attributes or kind of the structure of the XML. You can remove nodes, add nodes, change values.
I guess it's always a string for the last part of the modify. Like the first part's the XPath, right? And with because it's XML, it always has to be a string, right? You can't say like an int or something or.
Yes. It doesn't have to be a string. You can put in XML nodes too. You could say, as we'll see in the samples, in the demos, insert into this XPath, this XML node, and values. So we can see here. So the modify, this is kind of the syntax for an update or modify. So replace value of and the XPath location with, and then your value. Since this is we're updating a value, you have to reference that location as well with the square brackets, saying replace the first occurrence of the value. That's a required delimiter there. And then you say what you want to replace that value with. Say if we are updating an attribute, or we locate where the attribute is. You know, we say this is the where part, category parts, and the text or the value of that field equals bolts. So this is the second part of the where clause in the modify. So we are replacing the value of a name node, of the first occurrence of a name node, where the attribute categories parts, for the nodes, for the first occurrence of that node, where the name value is bolts. So change it from bolts to bolts short is what that modify statement does there. Shredding with dot nodes. You use it kind of in conjunction with the methods before, the query and the values. And what nodes does is it turns an XML string into referenceable columns. So kind of put these backwards to help explain it. So you'd say from your XML stream, and you'd say dot nodes, and then you say what level you want to pull the XML out of, or what level you want to shred. And then this is your table alias and column collection. So these two alias names are required. You can have them whatever you want, but for this sample I named them as such. So column collection, and then in your column selects, you say select column collection dot query, and then from there you use the extensions to look at the whatever XML level you're interested in. And the FLWOR expressions. So you use it to iterate over a section or a chunk of XML. For and return are the two required fields, but you can have a let, an aware, and order by in there as well. So for you're defining what kind of the input XML name is. Then instead of declares, you use let as a term to declare variables inside of there. And then you use where to kind of filter on those variables or the XML value that was passed in. And then ordering, that's how you order the output. And return is you can define a whole new XML structure if you want as the return output. On to the fun part. So we're going to do one table example, and to look at the data. First, we'll go over the dot value method. And here's the data on the right, the raw XML. The first column we're selecting, we say select the vendor XML, which is the column name, dot value, and then we're looking for the second occurrence of the name node and get the value of that node. So we can see here that the value is tent in the second occurrence of the name node. The second column is getting the value of the attribute, so name / attribute, category attribute, but the second occurrence of it, and we can see that it's shelter. This is the XML attribute here. And then the third column is tent2, which seems kind of weird. You don't see it in this list. It's vendor XML dot value and items / item, and give me the second occurrence. And when you don't define or if you kind of stop that XPath high enough, it just combines the values of everything underneath it. So tent and a 2 there.
Oh.
So it's useful to, go as deep as you want, or at least be aware of if you don't define it deep enough down the chain, it's just going to squish all the values together. So now we'll cover the .query method. And this one, we say vendor XML query items and item name. So what this does is it returned all of the name nodes, just went down through our whole XML and returned this row, returned this one, returned this one, all the way down through all of them. And then I said, query items, item quantity on hand as the quantity on hand nodes. I just did the same thing, except the quantity on hand nodes. It doesn't return properly formatted XML, just returns the node sets that you are asking for. So as I mentioned before, you can use the square brackets. When you're using .value, you have to use the square brackets. But we're using the .query, so this one will be return the first occurrence of the name node. Let's see here. I changed my demo here. Didn't pull down the latest code. Go on to exists. Okay, so we're going to fill our demo table with more XML. Right now, it only has one row in it with this large XML set. We're going to insert a whole bunch of kind of one-off little XML entries. Close this out. Make this larger. So for the with the exists, it returns a 1 if the XPath you're looking for exists at all in the entire set. So the first column here is a has name node. If this exists at all, then return a 1. And we can see in this XML here, here's that first row we were looking at earlier with everything in it. And then I kind of re-entered them, but broke them out one by one per row or per statement. And the name node exists in each one of those rows. So all of them are 1s. Then the next one I look for, check doesn't do an exist on the name node with an category attribute, and they all do except for the very last one. You can see here that it's empty. There's no category attribute. There's no real name associated with it or a quantity. So the has category attribute is a 0 for that entry there. The next column has a category attribute where it equals tools. We can see here that the only rows where it's true, is the first one that has everything, and the 4th row and the 5th row both have tools, so we get a 1. All of the other rows, except for the first one, they're either shelter, food, or parts, or don't have it at all, so the exist returns a 0. And then, the same thing except for looking for parts, and we only have one XML statement with parts in it, so we see a 1 in that column. Okay, the .modify method. So let's run these. So this one is looking For, let's see here. So repeat that same query as before, except where we're going to filter it and say where exists. We have a name category, or where there is an XML entry that doesn't have a category associated with it. And that returns our kind of placeholder XML. No category, doesn't really have a name associated with it. And what we will do is we will use the modify to delete the XML. So delete the first occurrence of the item node where that is 0, where it doesn't have the category attribute. So we can run our query again, and now we see that we've emptied out that XML node. So now we're going to use the modify statement again to insert XML. So enter, right now we have just the root items. So we're going to insert an item node or item set with the name node of bolts and the category of parts and quantity on hand of 100, where the category attribute doesn't exist. So it'll find this XML node. So we'll do that. One row affected. And here's our bolts, the one that we just created, or the XML row that we just inserted this parts category, bolts, value, and quantity 100. So you can see that using the modify, you can add a set of XML nodes in.
So the screws are there because the previous query
yeah.
was in the transaction, right? And so it really wasn't empty.
The screws were there previously.
Yeah.
We didn't see it because we were looking for XML nodes, or sorry, rows where the XML did not have a category attribute, and it was only that last kind of that placeholder XML row that didn't have an attribute. Screws already did because it had the parts category attribute set. All right, so we did the insert. Okay, so say we messed up the name, and we really wanted it to be bolts short.
You're doing regular strings in here. Could you do nchar strings as well? Does it support that?
So the question was, we're using varchar strings here, could it support in varchar? And yeah, it could. So as a known data set, not to be double byte. Okay, so like in the slides, what we're going to use is replace the value of, using the modify expression, replace value of the name text, where the category is parts, first occurrence with bolts short, where we have a name node with the category of parts, first occurrence, equals bolts. So that will catch this row here and update it over. We'll run that. Now we can see that it switched that it found that XML with the right parameters and updated the value. All right, so on to the nodes method. So as I mentioned earlier, it requires different syntax. You can't do, selecting from our table and use our XML column that's on the table and do nodes. It has to be an XML stream. So let's declare some XML, fill it with the top one XML value from our table, do XML nodes. Oh, you have to use that table alias and column collection on there. So we'll do the same thing, declare an XML variable, fill it with the XML from our table, and do a select from our XML variable nodes, and we'll choose at the name level, or stop at everything past the item level as table alias and column collection, and we reference it by saying column collection dot query or value, just as before. So hope that one won't work either.
You didn't select
Oh, yeah, there.
So is table alias
old
an
comment.
XML kind of keyword thing?
No, this can be anything.
You can't just say as column collection.
Yeah, no, you can't just say as column collection, because then, and it doesn't have to be
then
column
it's a table,
collection,
not an XML.
because now it thinks that text I typed there is the name. Blah. Have to update the table references there, so it can be blah column collection. So okay, so the first column here is just column collection name. So return, queries the name and return all the XML fragments, because using the query method returns an XML fragment. Name text, which would return it would return the value, even though this is the query method and there's a value method. Using text returns the value of whatever element or attribute you're referencing in the XPath. So you say .query, and you're either getting the element or the attribute, and you say /text. It returns a value here, but this value is considered XML. So we can say quantity on hand, and that returns the quantity on hand query. Quantity on hand returns the quantity on hand XML fragment. When you say .value, you have to say you have to define which occurrence you want, the first, third, or last. Even if there's one instance, you still have to say, give me the first one, and define the data type you want back. You can see here varchar, so the value is varchar. So this one says ax and it's not XML, because we're using the value function, defined it as text. Whereas this ax over here was using the query method to give me the value, and query always returns an XML fragment. So this kind of shows the differences there. And then getting the value of the category attribute, we say dot value, and then in parentheses we say the name, the attribute name, and which instance of it. And then we can see here that we got all of the category attribute values: tools, shelter, tools. Okay, on to the FLWOR order by return.
So if you click on those node name value with text things, are they just the text string room?
Correct. It is just the text.
So they're just different in type, but really they're just the same word, right? One's a text string that's the text, which is the text part of it, and the other is like an XML-ish text string that is the inner text of the node or something.
Yeah,
right?
the meat of the data is text, but how SQL sees it internally is it sees the query, the .query method results as XML. And when you're using the value method, it sees it as, in this case, text. So if you're using the .query to get a value, you need to, potentially do conversions or treat it appropriately. Okay, on to FLWOR. So, like I said earlier, for and return are required. So we are doing a select from our XML table here. The first column is where we're going to do our FLWOR statement. So you do vendor XML.query, and then you do your single text to define a string in here, and you say for, and then you declare a variable here for whatever level you want it to process. So it's going to iterate over each occurrence of the name node in this big long string. All the other records, it's just one occurrence, so we won't see lots of iterations. And this is just a real simple one. So for every occurrence of the name node, return the name node. So you can see here, for each occurrence, it didn't do any manipulation to the name node, it just returned it right back out. So this one, it's very similar, except so for the name, for declaring our name node, just a reference, for every name occurrence, return the string of that node. So instead of returning a bunch of name XML fragments, it returned the values inside. So you can see here, ax, and then tenth is the next one. And then, for all these other ones, it just returns the value inside the name node. Bolt short, bolt short. So here's an example of declaring a kind of an internal variable on here. So we say for the name, for every name occurrence node, let $string name be equal to, so use a little, equal to the string of the $name, and return the string. We get the same result. It's just a little cleaner coded, or if you're going to be adding more logic inside there, you can do the string conversion inside it. Okay, let's add on order by here. So in the first column, for every occurrence of the name node, set it to name, and then let the string name be the the string value of the name node, order by string name, and return the string name. The second column is the same as the first, but without the order by. So we can see here that the value it went through all of the XML at the name node and grabbed all the name values, and then in the output it ordered them. So we see it alphabetically: axe, broom, spaghetti, MRE in Spanish, folding shovel was one, mystery meat, and then the unordered list, it just went through the value of the XML as it was in the table and returned axe, tent, broom, pup tent, sleeping bag.
So can you put an order by after the from on this one, or does it not order XML elements?
So
if you said
so the
order
question
by
was
ordered or whatever.
So the question was ordered by.
Well, you can't say ordered. You probably have to duplicate the query or something, right? But,
yeah, can you have the order by after the from, and that would just reorder the entire result set, not the values inside of it. And it needs to be in here because each of the ordering is done when it's looking at that one table, table cell.
I just wondered if you could order the whole result.
Yeah, you could have another order here. Probably.
But then you have to duplicate that query, right?
Yeah, let's try it. Let's check it out. Order.
If do that because of the,
Oh, so you would have to repeat the
you have to
XML.
repeat that vendor XML query piece, right?
Yeah. All right. Okay, so this one, we kind of do some of the same logic of, setting creating a name variable for every occurrence of the name level. We do the string name conversion again, but in this one, we reference an attribute inside of whatever the current name level is. So we say order by the name node, its category, ascending, but then just return the string name. So when it goes over this long list, it's going to order the results by looking at each of the categories here. So we can see here that it did pizza MRE because it's food, and then mystery meat, which is food. It started out by ordering by all of the F's first because the distinct list of category values, it's food, tools, shelter, and parts. So it's going to start with the F's first. So that's a way to kind of to drill down further inside of the XML node that you are iterating over. Here's an example of using the where. And we are again drilling down further into the XML node that we are iterating over and filtering on the category attribute where equals parts. So this won't return any value unless the category is parts, and we can see here in the first column it doesn't return anything until it gets down to the rows that actually have parts as the category. And this one's a little bit more fun because we will, and I spread it out to make it a little bit more legible, but we're going to go iterate over one step higher. So for every occurrence of item, put that into an item variable and return basically a new XML structure. And when you're referencing the item, well, in this case, the item, when you're referencing one of the variable, either the main looping variable or any of the variables you declared in the let's part, it has to be this escaped with the curly brackets. Make it bigger here. So what we're going to do is we're going to return an XML set with the item node, except now we're going to uppercase. Can't really see it down there. We're going to uppercase the text, capital I, capital N, capital C, by this here. So return an item node, and then within that a name node and the category. Set the category equal to the category attributes of the current set we're iterating over. And then close that attribute and close the opening name tag. And then insert the current item's name text. And then close the name node and open a quantity on hand node with capital letters. And insert the current iteration quantity on hand value and close it. and then close the item tag. So let's run that. And we can see here that we'll click on that one, and then we'll open this one, and we can see what it was. And using that flower statement, we flipped it over to it rebuilt the XML, filling in the category attribute here, the name value there, and the quantity on hand value here. So I built a similar XML structure, but you could totally build, some other XML structure if you wanted to. You could use it to clean up XML and have a much more robust flower statement here to transform it into XML that you're looking for. So we got quick review. We covered query, value exists, modify, and insert, replace, and delete with the modify. We shredded stuff with nodes and went over the flower expressions. Right.